A first-order linear differential equation is a first-order differential equation which can be put in this form. Dy dx plus some function of x, p of x times y, equals another function of x, q of x. And these p of x and q of x are continuous functions of x on some given interval. The above form of the equation is called a standard form of the equation. And here's an example, although it is not yet in standard form. We have to manipulate this equation to get it into standard form. And so we start by dividing across by x, and we get dy dx equals x plus 3 over x times y. And then we bring the y term over to the other side. And now we see that this is a first-order linear differential equation in standard form. And there's a trick to solving these equations. To solve it, we multiply the entire equation by something called the integrating factor, which is a function of x. And this is the formula for the integrating factor, and it's a very special function in that its derivative, let's call the integrating factor I of x, its derivative is px, this coefficient of y, times ix itself. And you can check this out easily because ix equals e to the power of the integral of px. Its derivative is e to the power of the integral of px times the derivative of the integral of px, which must be px. So the derivative of this function is px ix. So when I multiply my equation across by ix, on the left I get ix times dy dx plus its derivative times y, and on the right hand side I just get ix qx, which is a function of x. Now this, the left hand side of this equation should remind you of the product rule from Calc 1. And so here we have a function times the derivative of y plus the derivative of that function times y, and that is the derivative of the function I of x times y. So using the product rule, I get the derivative of I times y is y prime times I plus I prime times y. And so now I can change this equation, my differential equation, to this form by reversing the product rule. So now on the left I have the derivative of y times ix is ix times qx, a function of x, on the right. And now if I integrate both sides, I get simply ix times y on the left, and then I get the integral of ix qx dx on the right. And I'm just adding c here to make absolutely sure you do that when you solve the equation. And if I can integrate this function, then I can find a solution to the differential equation by dividing all of this by ix. Let's look at an example. Let's start with the first example. Remember, it's not in standard form. Before I start to apply this process, I must put the equation in standard form. We've already figured this out. It's dy dx minus 3 over xy equals x. The next step is to decide what the integrating factor is, and that's e to the power of the integral of the coefficient of y here, dx. So that's e to the integral of minus 3 over x dx, and that turns out to be e to the minus 3 times log of x, which is e to the log of x to the power of minus 3, so that's x to the minus 3. So our I of x, the integrating factor, is x to the minus 3. Now the next step is to multiply our equation in standard form by x to the minus 3. So we get x to the minus 3 dy dx minus x to the minus 3 times 3 over x, so that's minus 3 over x to the 4 times y, equals x to the minus 3 times x, which is 1 over x squared, or x to the minus 2. Now remember, we did this because the left-hand side is going to be the derivative of y times the integrating factor. So this left-hand side is the derivative of y times ix. And just to make sure that you've done everything properly, you can check that when you differentiate this, you get the left-hand side of this equation. And this is equal to what we have on the right, which is x to the minus 2. The next step in solving this equation is to integrate both sides of this. And the left side is easy to integrate because it's written as a derivative. So the integral of what's on the left is just x to the minus 3y, and the integral of what's on the right falls out of the power rule. That's x to the minus 2 plus 1 over minus 2 plus 1, so that's x minus x to the minus 1 plus some constant. Now we're going to solve for y by multiplying across by x cubed. So we get y equals minus x squared plus c times x cubed, and that's our solution. Of course, you can always apply this when you have an initial value, and at the end you can plug in the initial value to find the value of the constant.